Solve the equation cos 2x minus 3 cos x minus 1 is equal to 0, where x is between minus pi and pi. So because we've got pi, we're going to be using radians. One of the problems we have with this one is that we have cos 2x and a cos x. These are different variables. This is cos of 2 times an angle. This is cos of 1 times an angle. What we need to do is make the variables the same. So we need to solve cos 2x minus 3 cos x minus 1 is equal to 0. And we have cos 2x is equal to cos squared x minus sine squared x. These are identities that you really should know, whether on a formula booklet. Or the thing with cos 2x, there's three possible ones to choose from. 2 cos squared x minus 1, or 1 minus 2 sine squared x. Now because this is cos x, we're going to choose this one. Okay, and we've got 2 cos squared x. So we're going to replace this with 2 cos squared x minus 1 minus 3 cos x minus 1 is equal to 0. Be careful how we write this. This is a squared and this is a multiple. And then we try to make this look like a quadratic. So we're going to get 2 cos squared x minus 3 cos x minus 2 is equal to 0. This is a quadratic in cos x. Therefore, we can solve it by taking the product, which is going to be 2 times minus 2, which is minus 4, and the sum, which is minus 3. Then we want two numbers which multiply together gives us minus 4, and if we add the same two numbers, we get minus 3. The possible answers are minus 4 and 1. We just check that. If we check minus 4 times 1 will give me minus 4, so the same as the product, that's okay. And minus 4 plus 1 will be equal to minus 3, which is the same as the sum, so that's okay. Both things have to agree for it to have to work. And then we take the quadratic and we split the minus 3 cos x up into minus 4 cos x plus cos x. So we're going to have 2 cos squared x minus 4 cos x plus cos x minus 2. We haven't changed the meaning here because if we add these together we get back to this. And then we factorize by grouping. So grouping these two together, it's a common factor of 2 cos x, that comes out, and we're left with cos x minus 2 plus, and there is no common factor here, so we'll just put in brackets and we'll put a 1 in front like we did in the previous example. So we've got the same thing in both brackets, we're okay. So this and this will come out and we'll be left with 2 cos x plus 1. So we're going to have cos x minus 2 brackets 2 cos x plus 1 is equal to 0. So either cos x minus 2 is equal to 0, which will mean that cos x is equal to 2. Alarm bell should ring here because cos x cannot be bigger than plus 1. And therefore this or less than minus 1, so this is outside that, therefore there are no possible solutions for there. So not possible, so there are no solutions. So or 2 cos x plus 1 is equal to 0. Cos x is equal to minus a half. Note that it is negative, but cos to the minus 1 of 1 half is pi over 3. We make our quadrant thing and we've got South Asian Tennis Club. We want to know where cos is negative, so it's going to be in the second and the third quadrants. So in those quadrants we draw our angle with against the x-axis, so pi over 3 here, pi over 3, and we are solving between minus pi and pi. So if we start here, this is 0, if we go back this way, we're going back, if we go this way, we're going back negative angles. If we go around clockwise, it's negative angles, so we're going to go pi, minus pi, plus pi over 3, or pi minus pi over 3. Okay, so minus pi plus pi over 3, so it's like being minus 3 pi plus pi over 3 is going to give me 2 pi over 3, and pi minus pi over 3 is going to give me 2 pi over 3. And these are the only possible solutions for this equation.